The CubeSat form factor revolutionized the satellite industry by introducing a standardized, cost-effective platform for space missions. Standardization, lower development costs, and faster innovation cycles have led to a democratization of space. CubeSats are highly versatile and customizable platforms that can be used for a wide range of missions, including Earth observation, communication, technology demonstration, as well as interplanetary missions. Our solution is to build a nanosatellite docking module that can enable CubeSats to perform more advanced missions like on-orbit servicing and refueling. Such a docking module will have huge applications in building of structures in space, robotic systems for maintenance and repair of space stations, building fuel stations in space for refueling satellites, providing life extension, orbital transfer, and deorbiting solutions.
Our approach begins with dynamic simulations of the satellite and the docking maneuver using MATLAB and Simulink. These tools will allow us to create a model of the docking sequence, enabling us to refine our algorithms for optimal performance. For the structure design, we will use SolidWorks to create detailed models of the docking module. This design will undergo rigorous structural simulations and answers to verify that it can withstand the launch stresses and the impact forces encountered during docking. This ensures that our model maintains structural integrity throughout the mission. A critical component of our system is the vision-based guidance and relative navigation algorithm, which we are developing using OpenCV. This algorithm will process real-time imagery to enable precise navigation and alignment of the satellites during docks. Next, our docking processor board will be designed based on a Raspberry Pi with schematics created in KiCad or Fusion 360. This processor will manage the docking operations and communicate with onboard systems. As a proof of concept, we will demonstrate our system using a 3U or a 2U CubeSat equipped with a docking adapter. We plan to showcase the docking mechanism on a 3 degree of freedom platform with a robotic arm to simulate translation motion, alongside a reaction wheel for accurate attitude alignment during the docking phase. In addition, we will perform a fuel transfer demonstration between the chaser and target satellites, illustrating the functionality of our docking system. To facilitate real-time monitoring, we will develop a satellite control station featuring a GUI that provides live video feeds and telemetry data from the satellites, enhancing situational awareness during operations.
With time, the number of debris in the space is growing very fast. Currently, the number of debris that size of more than a cricket ball is at least 26,000, and that of more than marble, that is 1 centimeter, is at least 1 lakh. Collision with this kind of debris can have catastrophic results on satellites, such as damage on solar panels, battery explosion, and deorbiting of satellite. As space regulatory bodies push more for space sustainability and the cost of nanosatellite goes down, the need for onboard servicing is also increasing. Onboard servicing helps to increase the life of the satellite. Along with it, it also provides a way to deorbit a non-functioning satellites. With ability to deorbit a satellite, it also interests the defense scenario. Various reports suggest that the in-orbit servicing could generate a revenue of over 5,000 crore US dollars by 2031. India is also developing a Bharatiya Antariksh station, which would also need docking. Globally, several startups are now coming up for orbital satellite servicing. A startup named Starfish Space has successfully demonstrated capability of docking with their satellite called Otter. Another US-based startup, Orbit Fab, is currently working on in-orbit refueling. In India, startups such as Orbited are stepping in the field. The ISRO also aims to develop a docking, aims and demonstrate docking in November 2024 with its SpaceX mission.
Hello, I would like to introduce you to our team and the technical expertise they bring on the table. Coming up first, we have our team lead Aman from Aerospace Department. He has a lot of expertise working with electrical subsystems. He is the project manager of Student Satellite Program and has been working on the electrical power system of CubeSat. Next comes Yash from Electrical Department. He has worked on both electrical and communication subsystems. He has been working on the deployable antenna system for CubeSats for seamless communication. Next comes me, that is Yashodan, and Nivedita with a combined background of mechanical and aerospace engineering. We both have worked on the design of the CubeSat as well as analyzing it from the structural and thermal aspect. And lastly, we have Parkadeep and Tanmay, who have been working on attitude determination and control systems of the CubeSat. They will be responsible for designing the control algorithm for the prototype.
The Indian space program started off in the 1960s with a humble beginning and an aspirational vision, with a focus on leveraging space technology for the common good. Since then, ISRO has gained global recognition for conducting extremely ambitious yet highly economical missions, showcasing its innovative and frugal engineering approach. We want to build onto this legacy with our innovative docking module to provide on-orbit servicing and space debris removal services from India for the world. We want to solve the global problems by combining our engineering talent, research capabilities, and our responsible approach towards space exploration.